Welcome back to my channel. I'm Brian Kafke, and this is lesson 33 in the Master Databricks and Open Source Apache Spark series. This video, we're going to be covering Goodbye Koalas, Hello Pandas API on Spark. This is an exciting topic, so stay with me. I'd also like to ask you to consider supporting me on Patreon, where you become part of my inner circle among the benefits, which also include ad-free videos. So check it out, and let's jump. There is a link in the description to the notebook which I'll be using, as well as the data file. So if you want to follow along and do this yourself, you'll be able to do that. So what is the Pandas API package? In a nutshell, the Pandas API is a library used in place of Pandas that switches to functions to use Spark data frames instead of Pandas data frames. Now, prior to Spark 3.2, this was a separate library called Koalas. And I did a video, actually my last video was all about Koalas. But now they've integrated it right into PySpark so that you don't have to do a separate install. It's also, I think, so they can integrate better the functions of what it does with Spark itself. Documentation links here. If nothing else, it's worth it just for all the links I'm giving you because there's a lot of things here. Here's a reference to the Pandas API in Spark, introduction to, which is a good blog, user guide, all kinds of stuff. Migrating to, if you've already been using Koalas, which has been around a couple of years, so there's probably a lot of people out there that do. And also a nice blog introducing, what is the Pandas API in Spark. Now, to use the Pandas API on Spark, you will need to use Apache Spark 3.2 or above. As of 3.2, you can still use Koalas, but they're deprecating it, and it's uncertain how much longer you'll be able to use that if you want to go into the newer versions of Spark. So if possible, you probably want to just go to the Pandas API. If you're using Databricks, you need to use the Databricks Runtime 10.0 or above. I'm actually using 10.2, so they're enhancing this very quickly. There's a link here that talks about releases of Apache Spark, so you can also take a look at that. A lot of nice features came out in 3.2. So let's talk a little bit more about what is the Pandas API, and there's a link here that you can get into that will explain more about what exactly it is in the details. But I'll give you a few things about it before we jump in. You should know that Koalas, and now the Pandas API in Spark, was inspired by Dask, which is an open source Python-based and Python-only scale-out framework for the Pandas library. So you could just basically switch out using Pandas and then switch in using Dask, and you're good to go. So the people at Databricks got the idea, well, why don't we do the same thing with Spark? We could just swap out the library. And they did a great job with it. It started as Koalas, but then there's something called Project Zen. They wanted to completely integrate it so it's seamless. The idea behind it is you don't need to learn a new Python API, which basically just means the Pandas functions you already know. Just use Pandas. And behind the scenes, if you swap out the library, then you will get the same functionality on Spark. But also it's going to be scaled out and you don't have to do anything. Of course, the goal of this is ultimately sales for Databricks, right? But it eases the migration from local Python and Pandas to Spark data frames. Almost no changes to the code are required. That doesn't mean you don't have to know anything about what it's doing, because obviously it's a very different platform, but it's going to make it a lot easier. So this Pandas API does implement most of what you'd probably commonly use in Pandas, which is really nice, and we'll get a better look at that in the demo part of this. In addition, the Pandas API do a lot to support user-defined functions over the cluster, which is really good. And of course, behind the scenes, it's using the newer Python user-defined function APIs. For an explanation of why they did this and everything, you can actually go to the Jira blog here, where they talk about what they were trying to do and what they're fixing. What is not supported? Well, according to their own documentation, they don't officially support structured streaming yet. I think that's going to be one of their quick fix items. And some Pandas data types are not supported because basically Spark doesn't support them. And of course, just because of the way Spark works, Spark uses JDBC to connect to relational databases behind the scenes, and so you would need to make that change as well. So there's a link below here which gives you an explanation of best practices and how to code properly for using the Pandas API in Spark. Should you use it? Should you go with this? What about Dask? Should I use Dask? That's a really good question, Brian. So the answer is you might want to use Dask. And obviously people at Databricks don't want to tell you that because they don't own it and they don't make any money if you use Dask. But let's step back and think about this. You started using good old Pandas and you're happy and you're going along good and there's no reason to change, right? Okay. But then something happens and you end up getting some data that's just too big. Somebody gave you a project, you end up with, say, half a terabyte, a couple of terabytes or more, and you just can't work all in memory. And that's the problem with Pandas, right? It has to squeeze everything into memory. So the first thing that would really be the easiest to do is just try installing a new package right where you are and see if it solves the problem. And that's what Dask is. It's an in-place install and go. As I mentioned, it's all Python, so it won't really affect your project or your environment very much, and it scales out. So if you do need multiple machines, you can support them easily with Dask. Technically, Dask should allow you to scale up to the same level as Spark, but I'm not sure I'd be quite as confident on that because I haven't tried it and it doesn't seem to be used as much in that use case, but that's what their documentation at least seems to say. My own thought is, if Dask doesn't cut it, then you can switch over to PySpark Pandas, and then you can use either the PySpark API directly or use the Pandas API. So in short, my own recommendation, which I also said in my Dask video, is start with Pandas, go to Dask, and then if necessary go to Apache Spark. And I say that because, again, parsimony. Why jump to something like Apache Spark, which is a completely different platform, really suited ideally for the cloud, etc., if you don't need to. Now, having said that, if you are a very cloud-based organization and you really want to be on the cloud and you want to have things done as much as possible in the back end for you, then Apache Spark, aka Databricks, I wouldn't just say open source Spark, but really Databricks would be a good option. I'm going to switch over now to the light theme so that it's a little easier to read. And what I want to do now is the R test. And what I call the R test is I'm going to try running Pandas code that I know works well, and we'll prove it in this video. And then I'm going to try the exact same thing in the Pandas API in Spark. Does it work? Does it not? How difficult it is to figure out what the problem is and then get it working and proceed. And that's, I call the R test, because if it's really horrible, if I can't get simple basic statements to work, then let's face it, I'm going to abandon it and run for my life and try to find something else. Right off the bat, we need to bring in the Pandas libraries here, right? So we're going to bring in Pandas and the other libraries like NumPy and Matplotlib. And notice right off the bat, it says Matplotlib Notebook is not supported in Databricks. Try using Matplotlib inline instead. So let's do that. Just going to run that statement here individually. Looks good. And that's really just a Pandas thing on Spark. Okay, now we need to bring in our PySpark Pandas library. And while we normally bring in local pandas as PD, that's kind of a Python standard, we're going to bring in the PySpark as PS. And we need to do that so we can distinguish the two, right? So let's bring that in. And when we want to call functions that are part of the PySpark pandas, we're going to use PS, which means to convert code, we're going to swap out PD and replace it with PS. To support this, I do provide you with your very own copy of a file, which I got from AdventureWorks that Microsoft puts out as a test data set, called Fact Internet Sales CSV, and you can see it here. I loaded it to the default location, but you can put it wherever you want. So migration notes, be sure to change any pandas PD references to the PS references. In other words, PD dot read something or whatever to PS if you want it to be migrated to the PySpark Pandas API. Also, be sure to change all Pandas data frame names to the correct Pandas API data frame names. I use a prefix so I know which is which. And I like to do that because there are differences, right? You're working on a completely different platform. You still have local PD, right? Local pandas that works just like you've always used, and that works only on the driver. But when you want to have the scaled out data frames, you're going to use the PySpark Pandas API data frames, which is different. And I think it's important to know which you're dealing with at any point in time, so I name them differently so it's really clear. I found that in some cases, very rare, the PD function format didn't work for me, and so I swapped it over to using the data frame dot method syntax. In other words, instead of PD function and then passing in my data frame to do something, I changed it to the PySpark API data frame name dot method. That may not be an issue for you, and I may have actually been making a mistake in my coding. I'm not sure, and it may have worked if I had done something else different, but that did solve my issue. So just consider, if you have a problem with one, just swap to the other approach. Real simple test right off the bat is, let's try just seeing if I can get the code complete. And if I go to the end of this line, PS read underscore, I can hit the tab key, and at least I can see, yes, I get support for function completion, right? What functions can I call here? So that's good to know. It should be there, but I like to test it. I can also, of course, do help, and I'm doing control enter, by the way, to run these cells, and just running that, and help PS. Because I linked this prefix to the module, it gives me all the help of what's available in here, which is handy to have. And if I need help on a specific function, I can just use the ps.function name and I can get help on that function. I'm using PS because I want the PySpark Pandas API documentation and not the PD read CSV, which is the Pandas documentation. As I said, we're going to go Python Pandas almost consistently throughout the book. So starting here, we're going to just load in LPDF sales. I use this prefix local pandas data frame LPDF. And what is it in the data frame? So that's my standard. I prefix it. I'm going to be using the good old PD read CSV, and then I give it the path and nrows just to limit this. And I also want to test, does it support the nrows limit parameter, because I found that in Dask it didn't, so I was a little curious if it would work here. No problem, of course, for pandas, but let's try it now with the Pandas API on Spark. I prefix this data frame with PSDF, so Pandas Spark data frame, and then again sales. So I will always know that this is actually the Pandas API data frame and not a local Pandas data frame. Same exact format of the statement I was using before. I'm just going to run it, and I get an error, but it has nothing to do really with the API per se. It doesn't like the way I'm formatting my path. This worked fine for local pandas, but what it's doing here is it's assuming a prefix of dbfs colon, the local sort of drive, if you will. Then it tacks this on, or I tack this on. So I need to get rid of this dbfs part. Okay, and that worked fine, you can see. And that's what this statement really does too. I just fixed it right in place. So now I have my pandas data frame, and I'll display a couple of rows to see how that looks. And that's fine. That's my local pandas. And then I'm going to do the same thing to my PySpark or Pandas Spark data frame, PSDF. So they both work, and notice that I was able to use the head function on both. How do we confirm at any given point what kind of data frame or object we have? Because everybody may not do this prefixing I do to make it easier for you. What you can do is just use type and put the data frame name in as the parameter. And it comes back and tells us, yep, this is a Pandas core data frame. Yay for us. Going to do the same thing for a Pandas API Spark data frame. And it tells us right here, PySpark Pandas data frame. I like to get schema definitions of my data frame sometimes, what columns are in there, etc. So I can take the data frame name, obviously in Pandas, do dtypes, and I'll just display a few to not fill up my notebook page. And it works fine, of course. Let's do the same thing with our PySpark Pandas data frame, and works fine. One thing I will point out, notice that Pandas has an int 64, but Spark's converting it to an int 32. Let's try a few statistical methods here. We're going to just start out by doing something real simple, right? The local pandas, right? Dot sales amount describe. So I want to see that I can refer to a single column using the dot syntax as well as using the describe method. Of course, with pandas works great. Does it work with a Pandas PySpark data frame? And it works fine too. Now we're going to try the pandas get the average mean of a single column, and we'll try the same thing in the PySpark. And that works fine as well, but notice that the rounding seems to be different, right? The actual, when you get out to the finer decimal points, which admittedly are pretty far out, there is a difference. I don't know if one's better than the other, but something to be aware of. Now let's, again, very simple. Let's just refer to a single column using the bracket column name syntax. I'm going to run it for both. Shift Enter. And you notice it works fine here for pandas, of course. When I did the PySpark data frame, Pandas API, I get the same thing fine. The only thing I would notice is that when it outputs, it doesn't do this sort of head tails kind of thing, which you get, which is kind of nice. Instead, you get everything, and you can scroll down for the whole thing if you like. So if you don't want that, you could put a head function on it to limit how many rows you get back. So far, so good. I'm actually pretty impressed. Gotta say, it's doing what I would have wanted it to do. Okay, but can I filter with it? Well, let's try. Of course, again, here's my pandas version, and I'm filtering using the data frame with the column specified as the bracketed syntax, the condition here, and I'm just going to display a few rows, and I'm doing the exact same thing on the PySpark Pandas API data frame. Perfect. Now let's try a little more slicing and dicing, because that's what we're going to want to be doing with pandas. A common thing that you would do in pandas is slice the rows and then slice the columns. So here we're slicing the rows using the index. We're saying give me index 0 to 3, not including 3, right? So 0, 1, 2, and give me also just the product key. And I'm going to do the exact same thing using the Pandas API. And that worked perfectly, so great. And I will point out that that's something not supported currently by Dask, so that's a pretty cool thing. The part that's not supported is this idea of slicing by row indexes. What about selecting columns by index? Well, we're going to do the iloc method this time. We'll directly call iloc. We're going to take all rows in this case, but I only want the columns 1 and 2, and I'll just display it. Now that's pandas, and the exact same thing is going to happen in PySpark, and it looks good, so that's fine. This time I'm going to slice by rows, indexes 1 to 5, so 1, 2, 3, 4, and just these columns. Now one of the differences in syntax here is I'm embedding a list of columns as opposed to just giving it a single column, so I have to use the list format, which is brackets and then list the names of the columns in quotes. I'm going to do this on both again, and it looks good. Both seem to do it perfectly. I don't really see any differences. Finally, what about setting the index? Index has become extremely important, especially when you scale out data frames, because it's the sorting, right? And it's how things are kind of orientated. If I wanted to change the index to a specific column, then I can use set index, give it the column I want to use, in this case sales order number on my data frame, and just say, do I want to remove the original column from the data frame or keep it, which essentially means you have it as an index, but you also have it as a column in your data frame. Here I'll do this in pandas and just display a few rows, doing the exact same thing in the PySpark Pandas API. And works great. Now I can prove also, not only do I get an index change, but let's make sure it retained the column. Here it is, sales order number is still there. So very simple basic test, but in terms of the R test, I would say it passes pretty well. I didn't cringe at anything. It was pretty intuitive to solve anything I came across. So overall, I didn't really see many problems. So kudos. It's very nice, and I will say it was a good experience. You felt like, wow, this is actually doing what I want, and I can take my code and just sort of lift and shift, which is really, I think, the goal. So I really have to give them a thumbs up. They really nailed it, at least for the Pandas Data Frame API. Let me know in comments too what you think and what you saw as well. Your feedback's welcome. Takeaways is that the Pandas syntax was 100% match in what I got here, so that's good. I didn't, with the exception of that format path thing, but that really had nothing to do really with the API per se. I think that's just a more Databricks thing. The code changes needed to go from Pandas to the PySpark Pandas API was really minimal, almost nothing. I recommend naming your data frames in a way that distinguishes from the PySpark data frame versus the local Pandas data frame, because they're very different and what you would do with them is different. Read and follow these best practice guidelines and accept that this is a moving target. So that's really one takeaway I do want to emphasize. For example, I just did a video on koalas, my last video, and I'm like, this is great, all right, and all psyched, and I did the video, and then I realized that they just released, like 2 months ago, a new release of Spark, which says we're deprecating koalas and switching it in favor of the new PySpark Pandas API, which is great in one sense. But if you think about it, for those customers that jumped on board and said, great, we're going to go with koalas and maybe put a lot of code in, they got to rewrite it, right? They're going to have to go back and change it. And I get a feeling it ain't going to stop. So just be aware. This is obviously the technology itself is very dynamic. It's advancing quickly. So you have to be aware. You're going to have to make all your code a variable so you can just change it in place. I don't know. It's kind of challenging. I want to thank you. Please share, subscribe, like, especially like, because that always helps, and comments are welcome. I always like those. And please consider supporting me on Patreon so that I can do more of these videos and help more people as well as yourself. Link in the description. Until next time, I'm pulling for you. We're all in this together. Thank you.